Next, we'll talk about horizontal asymptotes. A horizontal asymptote of a graph is a horizontal line y is equal to some number b, where the graph approaches the line as the inputs increase or decrease without bounds. In symbols, we write, as x approaches infinity, that means increasing without bounds, the function values approach b, some number, which is the horizontal asymptote. And as the function values decrease without bounds, in other words, approach negative infinity, the function values also approach b. So let's take a look at a horizontal asymptote. So for example, in this rational function, we can see that as the x values increase, the y values approach this dotted green line. And as the x values decrease, head towards negative infinity, the y values also approach that green line. And that green line has the equation y is equal to 4. So y is equal to 4 would be what we call a horizontal asymptote of this function. So we would say as x approaches infinity, f of x approaches 4, and as x approaches negative infinity, f of x approaches 4. Why don't you take a look at this graph and see if you can identify the horizontal asymptote. So in general, this section is about rational functions, and a rational function is a function that can be written in the form p of x divided by q of x, where p of x and q of x are both polynomial functions. So for example, f of x is equal to 3x squared plus 2x minus 7 divided by x plus 3. That's an example of a polynomial function. And g of x is equal to x plus 4 squared over 4x to the fourth minus 2. That's another example of a polynomial function. It's just a fraction where the numerator and denominator are both polynomials. So one of the things we've talked about before is the domain of rational functions. So just as a review, the domain of irrational functions are all x values except those that would cause division by 0. So in other words, the denominator of a rational function cannot be equal to 0. So for example, find the domain of f of x is equal to x plus 3 divided by x squared minus 9. So again, we don't care about the numerator, we just care about the denominator. So we would say x plus 3 times x minus 3, that's the denominator factor, it is equal to 0. That would be equal to 0 if x is equal to 3 or x is equal to negative 3. So the domain would be all numbers except 3 and negative 3. And if you take a look at the graph of this function, you'll notice that at x is equal to 3 and at x is equal to negative 3, the graph has some very unique features. So at x is equal to 3, we can see that here we have a vertical asymptote, and at x is equal to negative 3, we can see there's a hole in the graph. And so we'll be talking about what those things represent in the next section.